So this is homework page 428, 910, 19 through 24. Some of this was just little questions. So number 9 was asking about pieces. The first one, I'm really hoping everyone did well with this because this is one of the big points I've been making. It says, is this a sampling distribution of p hats? Yes or no? No. Why? It is not a distribution of all of the possible outcomes for that scenario. It is a simulation, basically doing fake trials. So it is not all possible outcomes of size 100 from that school. It's not all possible samples of 100 students from that particular school. That should be your answer. Describe the distribution. For this one, I'm just going to kind of talk through because I didn't give you like specifics on what I'm telling you it had to be. But the P of the problem is 0.6. So it should be that mu of P hat equals P, which is 0.6, technically, if it worked out right. But if we're just looking at distribution here, we would say it looks like it definitely is centered at 0.6. We're kind of talking generally here. The shape looks fairly bell-shaped for the most part. And we're not going to get into like the spread exactly. Basically, we're just saying it looks like it's centered about where it should be, and it's symmetrical, bell-shaped. Oh yeah, it says any obvious outliers. Are any of the outliers like obvious? Not really. Like there's a chance that maybe there are two low outliers and maybe two high outliers, but that doesn't look terrible. Like it didn't look like something was wrong. And so as long as you mention that, right now I'm talking very generically for this homework. Now, it says, suppose that 45 of the students in the actual sample say they did all their homework last week. Well, in all of those dots, how many of them had all the way as far out as 45? None of them. So that's farther, like that's more of an outlier than any of our samples, any of our 250 samples. So does that seem weird if we got a number that's really far outside, even farther outside than any of our dots were? Yes. So that's the kind of connection you're supposed to be making at this point. So it says, suppose we did get 45 of the 100 students, and they all did their homework last week. What would you conclude about the newspaper's claim? Maybe the claim itself wasn't right if we actually took a sample and it doesn't end up anywhere on that distribution. So basically, like that's the whole saying of if we took only AP Stat students and found their GPAs, it probably wouldn't fit on the distribution of all students for a reason. That's kind of like what we're saying here from the other perspective. Number 10. Exact same thing as the sampling distribution of X bar. No, because not all possible samples of 20 girls of the 316-year-old females at that school.
So if it was, would it like explicitly tell you that all of the possible samples should be?
Yes. Okay. And like the only ones we did in class were like flipping a coin like 3 times or something like really small. Yeah. So like you probably should never expect to really see one. And if you do, they should explain it so well that it's very obvious. Okay. So it's pretty much, I just always want you to say no and understand why it's no. Okay. So describing the distribution here, again, fairly bell-shaped, probably centered about 64 inches, which is where it should be, so non-biased. Any obvious outliers? Maybe that one that's below 62.5 might be an outlier. I've got a couple dots on the high side, but maybe not outliers, maybe possibly above 65.5. Suppose the average height of the 20 girls in the actual sample is 64.7. So you could actually sit here and count, but you don't have to. Are there a bunch of dots? Are there a decent amount of dots that are farther away than 64.7? Yes, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, about 25 or so, 20, 25 of the 250 samples. So that seems fairly reasonable that we got something that far away from the middle, because it happens that often. Are you with me on what we're trying to find in 9 and 10? So that's like our thought process of what's going on with making the connection to today. Number 21 is multiple choice. A newspaper poll reported that 73% of respondents. We started all the way at 19 and did 19 and 20? Or did
Just
do
19.
20? Just 19, okay.
21.
Sorry, 19 was the one with the different sampling distributions. So I kind of want to very vaguely draw this. It's giving you a point right here saying that's the parameter. And so one of them is group stuff down here, and that's where the parameter should be. One of them, it says parameter should be here and group stuff here. One of them, it's kind of grouped there, but it's spread out a lot. And then parameter here, and they're pretty much all down there. So it shows 4 different sampling distributions. Which ones are unbiased estimators? So the arrow is your population parameter, and then the graph part is your distribution. So which one of those are unbiased? Which one of those are unbiased? B and C, why? They're centered where they should be. That's the whole point of unbiased, is they're centered where they should be. So this one's not centered where it should be, this one's not centered where it should be, so there's bias involved. Which one does the best job of estimating the parameter? We pretty much already knocked out A and D because because they're definitely biased. So which one's better, B or C? B, because it has much less variability than the first one, or than C. So we want unbiased. In addition to unbiased, we also want low variability. So B would be our best choice. All right, so now with 21, a newspaper poll reported 73% of respondents, like business tycoon Donald Trump, yes, this is old. The number 73% is a what? $73 is a what? A statistic, because it describes the sample. That is D. The name for the pattern of the values that the statistic takes when we sample repeatedly from the same population is what? This one's I don't love this problem. This one is supposed to be the sampling distribution, but the true sampling distribution would be if we took all of them. And I see where that's confusing. It's technically supposed to be E, but I'm not really concerned with that one because I think the way they word it takes away from the big point of what a sampling distribution is. 23, if we take a simple random sample of, okay, this is a good one and a lot of people get mixed up on this. If we take a simple random sample of 500 from a population size of 5 million, now we want to compare the variability of that to the variability of, it gives us different things. So the second thing it gives us is a sample size of N from a population of 50 million. I don't remember what I was, less than, equal than, greater than, about the same. I was much less, slightly less, about the same, slightly greater, much greater. I don't remember what order, but. Alright, so what does it mean by variability? Based off yesterday. What did we talk about yesterday that was variability? Standard deviation. So I am taking a sample from a population. So there's two things that get addressed there. One of them is 10% condition. Am I worried about 10% condition with 50 out of 5 million or 50 million? No, that's fine there for both of them. So the other thing that comes into play is finding the standard deviation. Well, what is our equation for standard deviation? What do I actually use in that equation? And what happens from this one to this one? The only thing I use in that equation is the lowercase n. Well, what did I do to my lowercase n? Nothing. So what's going to change about my variability? Nothing. So it's going to be about the same. So that's the whole point you needed to see is, well, if our sample size didn't change, our standard deviation is not going to change, so it's going to stay the same. It doesn't matter the population size I'm pulling it from because my 10% condition is checked in both of them. Questions on that one? Because you definitely need to know that.
Wouldn't it be, I don't know, I just thought about it the way that like if it was more people to choose from, you would have a more drastic like variability. Just because
But the variability, again, is accounted for, adjusted here. So our adjustment is still the same regardless. Don't overthink that one. Increasing the sample size is going to what? We talked about this yesterday and I said it word for word yesterday. If you, a bigger sample size is going to decrease your what? Your standard deviation, which is your variability. Same, exact same thing there. So that one is B.
so it doesn't change when the population changes, it only changes if the sample size changes.
Mm-hmm. Questions on anything related to any of that bookwork?